Okay, so as well as expanding brackets, sometimes you can just take a little shortcut, like say in ones like this, find the fourth term of. Now, if it's the fourth term you're looking for, count that through starting with 11, choose 0. So if it's 11, choose 0, 11, choose 1, choose 2, choose 3. So the fourth term is not 11, choose 4, it's actually 11, choose 3. Write your first term, write your second. So again, I'm just taking that from there and there. Now, following my formula, as I explained in the last video, it's 11. 11 take 3 is 8. And then the bottom number goes there. So on my calculator, I have 11, choose 3, which is 165. I have 1 to the power of 8, which is 1. Just careful here, 2 to the power of 3 is 8, but you also have to cube the x. So now I do 165 times 8. So that's 1320x cubed. So we immediately get the fourth term without having to do any expansion. In the next one, find the middle term of. Now, the middle term, what would that be? So if it's power of 8, I have 9 terms. So if you think of 9 terms, which one is in the middle? It would be the fifth term would be the one in the middle. So think about what your fifth term would be. 8 choose 0, 8 choose 1, 8 choose 2, 8 choose 3, 8 choose 4. So it's 8 choose 4. Put down your x, put down your minus 2y. Again, follow your binomial theorem, page 20. Top take bottom, 4, and then the bottom number goes there, which is 4. So 8 choose 4 is 70. X to the power of 4 is just that. Now, when you raise 2 to the power of 4, you get 16, and it's positive because it's an even power, y to the 4. So now I multiply 70 by 16, which is 1120, x to the 4, y to the 4. So again, you can straight away get to the answer without having to do the whole expansion. These ones are probably the most difficult ones with the binomial theorem. Find the term independent of x. So that means no x. Okay, so let's think about it. It's going to be 8 choose something. Here we're going to have the first part. Here we're going to have the second part. So I'm just kind of laying it out the way I see it in this question so far. Now, somehow I need no x. So another way of saying that is I need the x's to cancel. Now, how can I possibly make the x's cancel? Now, for example, if that was a 3, this would become x cubed and they would cancel. But if that's a 3, that would have to be a 5 because what we'd be saying is that 8 take 3 is 5. And then that becomes 15. So that's not going to work. So we have to go back and think, well, what would work? What could make the x's cancel? So if you're not sure, just go through some possibilities. But for example, I'm thinking, what if I had something like 6 here? Now, if I had 6 here, this is going to be power of 6. If that's a 6, then that has to be a 2 because that's the formula. And this will work because what ends up happening is I get, it's going to be 4. That's going to be x to the power of 6. Now, because this is in even power, the minus is going to be gone. So it's just going to be 1 to the power of 6 is 1. Now, 3 to the power of 6, we do need to work that out. That's 7 to 9. And I have x to the power of 6. So what will happen? We might actually just work out 8 choose 6 as well. So that's 28. So I'm going to put that over 1, just my usual. If something is a fraction, I generally put everything as a fraction. And hopefully what you can see is they now can cancel. So along my top line, I have 28 times 4, which is 112. And the bottom line, I have 729, and I'm done. And I can see this is independent of x. In other words, there is no x in that. Okay, I'm going to do another video now on using the binomial distribution. I won't be putting up that video just yet because I have to nip out, but I'll be back and I'll do it in a little while. So I'll just stop this one.